my STEM show by me, Rhea, and I'm going to be talking about neurology and how your brain perceives illusions and why it appears the way it does. So, what is neurology? So, neurology is the study of the anatomy, the functions, and the disorders of the nervous system. Today, I'm mostly going to be talking about the functions of the nervous system. So the nervous system contains the brain, your sensory organs, your spinal cord, and your nerves. The brain is the most important organ in your nervous system, and I'm going to be talking about how it perceives illusions. So I'm going to start off with the first illusion. So as you can see, um, squares A and B appear to be the same color, right? But as other squares start adding to the illusion and a cylinder is placed in the illusion, square B appears to be lighter than square A. This happens because the shadow cast by the green cylinder makes B look lighter than it actually is. This also happens because of the darker squares around square B. This has nothing to do with how your eyes are structured. This happens to do with how your brain perceives the lighting and the assumptions it's making about what it sees. So the second illusion, you can see a red dot moving across the screen and you can see a green dot flashing. It appears that the red dot is always a little bit ahead of the green dot. However, this is not true. The green dot flashes when the red dot and the green dot are in perfect vertical alignment. The reason why the red dot appears to be ahead is because your brain predicts a path of motion. It looks a little bit ahead of time to predict the red dot's path of motion so your brain can react to what it's seeing. So the third thing I'm going to talk about is the dress. So many people have seen this dress before, and it was a whole controversial topic on the internet a few years ago. So the problem was everybody was seeing the color of the dress differently. So 50% of people who saw the dress saw blue and black, 30% of people saw white and gold, 11% of people saw blue and brown, and an additional 2% of people saw something different. So why does everybody see different colors? So according to a study conducted by Belleville Conway, your brain makes assumptions about how the photo is illuminated. For people who saw the dress in white and gold, they assumed that the photo was illuminated by daylight, causing their brains to ignore the longer blue wavelengths. But people who saw blue or black, they assumed that the dress was illuminated with an artificial light, and therefore their brains ignored the longer red wave or the shorter red wavelengths. And people who saw anything else assumed that it was just lit neutrally. So a group at Giessen University concluded that the colors on the dress are found in daylight, which is bluish at noon and yellowish at dawn. And another study done by researchers at the University of Nevada inverted and edited the photos to appear differently. When they added more yellow to the dress, more people saw white and gold, and when they added more blue, more people saw blue and black. This probably happened because there was an equal amount of yellow and blue in the photo, and our brains couldn't decide which color it was, so everybody's brain made a different assumption about what they saw. So what does this mean? This comes to the conclusion that the way the photo and the dress is illuminated is perceived differently by people's brains, causing them to come to different conclusions about what they see. So to wrap this all up, it comes down to how your brain perceives things. Your brain always makes assumptions about what it sees in front of them, and as we know, not everybody has the same assumptions about things, and not everybody's assumptions turn out to be correct. And so that's really just our brain looking out for us, trying to make sense of what it sees. Right. That was my STEM presentation. Thank you so much for listening, and I hope you enjoyed. Thank you.